Hey, 8th graders, continuing our lovely time on algebra type problems. Today we're looking at lesson 24, which is Introduction to Simultaneous Equations. So, a system of linear equations is a set of two or more linear equations. When graphing a pair of linear equations in two variables, both equations in the system are graphed on the same coordinate plane. A solution to a system of two linear equations in two variables is an ordered pair of numbers that is a solution to both equations. So our two equations, x plus y equals 6, x minus y equals 4. So we plug in that ordered pair, 5 plus 1 is 6, 5 minus 1 is 4. So we start with Pia. Pia types at a constant rate of 3 pages every 15 minutes. Pia's rate is 1/5 pages per minute. If she types y pages in x minutes at that constant rate, then y equals 1/5 x. Pia's rate represents the proportional relationship y equals 1/5 x. So there it is in a chart below here for you. So we graph it. Y equals 1/5 x, goes through 0, 0. So now she typically begins work at 8 a.m. every day. On the graph on the previous slide, her start time is reflected as the origin, 0, 0. That is 0 minutes worked, 0 pages typed. For some reason, she started working 5 minutes earlier today. How can we reflect the extra 5 minutes she worked on our graph? So the x-axis represents the time worked. So we need to do something on the x-axis to reflect the additional 5 minutes of work. So we're going to move it 5 units to the, that should be left, not right, sorry. We translate the graph 5 units to the left to reflect the additional 5 minutes of work. So here it is. You can't quite see the 5, but that's okay. So the red line is her original equation, y equals 1/5 x. And the blue line is y equals 1/5 x plus 1. So we know it goes through at -5 because that's 5 minutes sooner than normal. And then we take that y-intercept, which is 1, from our graph, where we get y equals 1/5 x plus 1. Okay, now let's look at Sandy and Charlie. They run at constant speeds. Sandy runs from their school to the train station in 15 minutes, and Charlie runs the same distance in 10 minutes. Charlie starts 4 minutes after Sandy left the school. Can Charlie catch up? And the distance between the school and the station is 2 miles. So Sandy's average speed in 15 minutes, 2/15 miles per minute, because she runs 2 miles in 15 minutes. Having a hard time reading today. Charlie is 2/10 or 1/5 miles per minute because he runs 2 miles in 10 minutes. So Charlie's average speed is represented by y equals 1/5 x. Here's a chart that tells his running. Okay, so at 0 minutes in Charlie's run, Sandy had run 8/15 of a mile. So her average speed equation is y equals 2/15 x plus 8/15, because she had already had that 8/15, and then her average is 2/15 per minute. So if he starts 4 minutes after we graphed those two equations, their average speed, so you can see that Sandy starts at 4 minutes before Charlie. However, when they cross, we can see, and you can't quite see that. So hold on, let me pull it up on a graph. Apologies. So Charlie, y equals 1/5 x, and Sandy, y equals 2/15 x plus 8/15. So what you can't see in the picture is this right here. So their lines cross, but not at the 2 mile mark yet. And you can see that Charlie just barely gets there before Sandy would. So yes, Charlie can catch up to Sandy. Okay, so they intersected about 10, 1.8. So no assignment today. We're going to keep working on those tomorrow. and a little bit more. Take this opportunity to work on any makeup missing work you have or late work. If you're not sure, check GradeLink, ask one of your teachers. But otherwise, have a great day.